All right, so we want to talk about today solving these quadratic equations again. We've been doing this for a little while. There's a lot of information there. There's a lot of things to consider, and so we want to take a day to review some of these solving methods. Okay? Our purpose for today is to review the methods of solving quadratic equations. There are the standards that we're going to hit. All right? Your methods. You have to remember all the different ways we've talked about solving before. First of all, there's the easiest way of all, which is the square root method. If you can ever use the square root method, use the square root method. Okay? And you have to remember when. When does that happen? Well, if there is no linear term, or middle term, or b term, or however you want to talk about it, right? Remember that the um, standard form of a quadratic equation is that y equals ax squared plus bx plus c. The middle term or the linear term, anytime you hear the word linear, that's to the first power, right? We go back to our different functions and our different names for those functions. If the highest power was a 1, it was called a linear function. So your linear term is always this guy that is your x to the first term. If that's gone, so that you just have an a and a c, then you can use the square root method. Okay, and we'll review that in just a second. All right? If there is a b term, you cannot use the square root method. So if we do actually have a middle term, then you really need to get in the habit of trying to factor. Okay, we've got to get good at factoring. It will make our life so much easier. We don't just want to jump to our next method because the next method is very long, very drawn out, and there's very many ways to make a mistake. Okay, so we want to try to factor, right? And remember that we want to create two binomials from a trinomial and then set these two factors equal to 0 using the zero product property. And we'll review that in more detail in a second. Now, if you're in standard form and you have that b term and it will not factor, then yes, the quadratic formula is what you're going to have to use. But your life, again, is going to be so much easier if you look at it as have to use it instead of I'm just going to use it because I don't want to try anything else. Okay? Now, there is a fourth method for solving these, and we need to at least acknowledge it, and that's the graphing method. The graphing method is never a great method to solve anything, but it's there. We also make the tie between solutions of a quadratic equation and the x-intercepts of a graph. So if you have a graph, if you graph a quadratic function, the solutions of that quadratic equation would be the x-intercepts or where the graph crosses the x-axis. Okay, so we'll need to consider that in a second as well. All right, so you're going to get a handful of problems here where you can use any method you want. Okay, I'm going to walk you through a couple of these and walk you through my thought process and see if I can't help you develop your own thought process to make this make sense. So this first one, 6x squared minus 12 equals 0. The first thing I look for, right, is the equation equal to 0? If it's not, you've got to get it equal to 0. I've got to see where the y was. Remember, we're replacing y with 0. I got to see that. And then I make my determination on which method I'm going to use to solve. So now that this is equal to 0, I look and I see that there is no middle term, there is no b term, there is no linear term. That means I can use the square root method, and that makes me very happy because it's very easy to do so. To use the square root method, you have to get x squared by itself, right? The idea behind the square root method is to get x squared by itself so that I can square root x squared and get to x. Ultimately, I need values of x. So we add 12, divide by 6, And now we square root both sides. And so we get x is equal to plus or minus the square root of 2. Okay, you can square root 2 and get a decimal answer. That's fine for now. All right. The next thing I'll tell you about the square root method is don't forget your plus or minus. Right? Because the 2 is not a great example, but 4. What's the square root of 4? A lot of you guys are going to say 2, which is true because 2 times 2 is 4. But so is negative 2 times negative 2. So we have to use the plus and the minus side when we square root. Okay? So there you go. Number 2. First thing I'm looking for. Is this equation equal to 0? The answer is no, it's not. So you've got to get it that way. So we subtract 15, subtract 15 to get this 0 on this side. Okay? Now, it has a b term, it has a linear term, it has a middle term. So we need to try to factor this. Okay? So let's take a look. Trinomial factors into two binomials. We've got to factor this first term and put them as a first term in our parentheses, so x and x. Now I need factors of negative 15, and when I get these factors of negative 15, I'm going to plug them in here and here, and I have to remember that I'm sort of deconstructing FOIL, or I'm working backwards from FOIL, and FOIL tells me that the outs and the ins need to add to this middle number. So whatever factor pairs I put here and here, when I multiply them by x and x, they need to add to negative 3x. Your factor pairs of negative 15, 1 and negative 15, negative 1 and 15, negative 3 and 5, negative 5 and 3. If I were to multiply them by x and x, I would just slap an x on each of them and then add them together to get to negative 3x. Unfortunately, none of these will do that. So it's not going to be factorable. So now I have to go and use the quadratic formula, which is unfortunate because it's kind of a long thing, right? But the quadratic formula, which you need to know, is opposite b plus or minus the square root of b squared minus 4ac all over 2a. Now, a here is 1, b is negative 3, and c is negative 15. And so we plug this in and we go. So 3 plus or minus the square root of negative 3 squared minus 4 times 1 times negative 15 all over 2 times 1. Which is 3 plus or minus the square root of 9 plus 60 all over 2. We keep simplifying. 3 plus or minus the square root of 69 all over 2. And to find our two solutions, and remember that very often quadratics have two solutions, we've got to go 3 plus the square root of 69 over 2, and we've got to go 3 minus the square root of 69 over 2. And we've got to get these into our calculator and find the solution. Okay? So 3 plus the square root of 69, and then divide that by 2, will give you 5.65. And then 3 minus the square root of 69 divided by 2 will give you negative 2.65. And so those are your two solutions, here and here. Remember that very often we're trying to find two solutions. Not always, but for the most part. And that's how you do it. You split that plus or minus up when it's time to. Okay? All right. Next one. Okay, number 3. Again, the thought process here needs to be very systematic, right? First thing we got to do is get this thing equal to 0. And in order to do that, you might think you want to subtract 20p squared and 6p to move those over here. to get it equal to 0. But if you do that, I want you to pay attention to this. We would have to subtract 6 minus 20 and get negative 14p squared. And we've never tried to factor where that a is negative. I don't want to do that now. So my point behind showing you this is when you have to start moving terms around to get this equal to 0, make sure that whatever you do keeps a positive. So instead of subtracting 20 from 6, I want to subtract 6 from 20. So I'm going to move everything from the right-hand side over to the left-hand side. And I move them by doing the opposites, right? Because we're adding out to 0. Okay, we do that. These are all 0. So the right-hand side is going to be 0, which is what I want. 20p squared minus 6p squared is 14p squared. 13 plus 6 is 19p minus 3. Okay, we've got a middle term, we've got a b term. So we cannot do the square root method. We have to try to factor. Now, how do you factor 14? Well, you have a couple of options. You can do 14 and 1 or 7 and 2. And I'm going to try 7 and 2. Just because experience tells me that these numbers are not particularly large, the b and the c. So I might have to split my a up more to even out the numbers, if that makes any sense. Okay, now I need factors of negative 3 to put there. But when I'm deciding that, I have to remember that my outs and my ins have to add to 19. So as I create my factor pairs of 3 and negative 1 and negative 3 and 1, I know that I'm going to have to multiply one factor by 7, the other one by 2, and then add them together to get 19. Well, if I multiply 7 times 3 and 2 times negative 1, 7 times 3 is 21. Negative 1 times 2 is negative 2. 21 plus negative 2 is 19. So that's it. That's what I want. All right. So if that's the case, we have to link the 7 and the 3 and the 2 and the negative 1. And that's how we do that. And we've now factored. We don't have to worry about quadratic formula. Now, the zero product property says if I take this times this, I have to get 0. If that's going to happen, that means one of these two has to be equal to 0. So I set them equal to 0 to find out when that happens. You add 1, divide by 7, and that happens here when p is 1/7. Subtract 3, divide by 2. This happens here when p is negative 3/2. So my two solutions are 1/7 and negative 3/2. Okay? But we could use the factoring method here. All right. Now, got a couple more here left. Try these out on your own. Go through your checklist. Make sure that it's equal to 0. Look to see if you can use the square root method. If you can't, then try to factor. If it's not factorable, then use the quadratic formula. All right? Give it a shot. Stop the video, start it back up, and see what you come up with. All right, so did you get this? Right? So you had to add the 49 to both sides to get it equal to 0, and then you could actually factor this. Now, I went ahead and did it to where I factored the first term into 2x and 2x and the last term into 7 and 7. If you remember a long time ago, we talked about if you square root the first term and you square root the last term to get 2x and 7, and then if you multiply 2x and 7 to get 14 and then multiply that by 2 to get 28, your middle term, then you can just set your two factors into 2x plus 7 and 2x plus 7. But that takes a lot of experience, and if you don't remember that, that's fine. You should still be able to factor down to 2x plus 7 and 2x plus 7. Your factors are the same, so there's no sense in setting them both equal to 0. Just set one of them equal to 0, and then solve for x, and you get negative 7/2. Okay? So that's your solution. While we're here, I want to show you what would happen if you used the quadratic formula to solve this, right? Because I don't want you to freak out when you see it. So b is 28, so you get negative 28 plus or minus the square root of 28 squared minus 4 times 49, all over 2 times 4, which is 8. Okay, So you get negative 28 plus or minus the square root of, I believe 28 squared is 784. And it is. And if you multiply 4 times 4 times 49, then you also get 784. And so look what happens inside your radical. 784 minus 784 is 0, which is fine. The square root of 0 is 0. If you add 0 or subtract 0, you still don't change anything. So you get this, and you reduce down to negative 7 halves, which is what we got over here. So the quadratic formula will still get you to the answer. It's just going to look a little funny because that 0 ends up being in the square root. So I wanted to show you how to deal with that. All right? All right. Try this next guy. Remember that you've got to get it in standard form. ax squared plus bx plus c equals 0. So that might require you to multiply some stuff out. So multiply these guys out and then subtract the 27 over to get it in standard form. Okay, stop the video, give it a shot, and see what you come up with. Did you get this? It's factorable. So you had to multiply out x plus 4 times x plus 4, and you get x squared plus 8x plus 16. Then distribute the 3 to get 3x squared plus 24x plus 48. You subtract 27, and you get a trinomial that's factorable. You set your factors equal to 0, and you get negative 1 and negative 7. Okay? So, you choose the method that you want, but I'm trying to make your life easier. Try the checklist that we've been talking about. And if you can factor, then like I said, your life will be a little bit easier. Okay? Now, last but not least, the graphing method. We've talked about all the methods except for the graphing method. And again, remember that solutions for a quadratic equation are also called roots. They're also called zeros. They're also called x-intercepts because these are numbers that tell you where the parabola crosses the x-axis. So in the graphing method, we're going to be looking for where the parabola crosses the x-axis. So look at this first one. Okay, where is that parabola crossing the x-axis? This one doesn't cross the x-axis. So the solution here would actually be no solution. Okay, no solution if you're solving it with one of the other methods means that you're going to get a negative inside a radical where we can't take the square root of a negative number. Okay, so that's just a heads up there. Number 7, where's that parabola crossing the x-axis? Well, it's crossing here and here. So your solutions are going to be x equals negative 4 or negative 8. And then this parabola, the vertex is on the x-axis, so it's only going to hit the x-axis in one place, and that's when x is equal to 5. Okay, that's pretty easy with the graphing method. The problem with the graphing method is that the parabolas don't always hit the x-axis at nice pretty points. So it becomes very difficult to tell where those x-intercepts are. All right, but there you go. That's how we use a graph to find those solutions. There's our quick review. You have homework out in Canvas. Make sure you get that done by next time.